Hello everyone, welcome to Chapter 7 in Marketing Analytics. This chapter is all about pricing. So we're going to talk about different ways in which we can analyze what we do with pricing and what our competitors do with pricing. So let's go ahead and begin. The first formula that you need to understand is what's just called price premium. So price premium is just, the additional price of certain products compared to others. Okay, and so typically what you do in pricing analysis is you compare your price to some benchmark price. It can be the competitor, for example, and you just do a percentage calculation to see, what is your price premium as a percentage compared to whatever that benchmark is. And again, it can be a competitor, it can be an average of all competitors, it could be a weighted type deal. So let's do a quick example using this top formula here, price premium. So let's assume that you're working for Acme, and Acme sells bricks. Okay, and you know that Acme sells bricks for $2 each. I don't know if that reflects reality. I have no idea how much a brick costs. Okay, your closest competitor is Beta, and you know from a little bit of research that their bricks sell for $1.84, so yours are clearly more expensive. So the question is, what is your price premium? So using the formula you see above, basically it comes to 8.7%. So you have a 8.7% price premium over Beta. So is that a cause for concern? Is it concerning that your brand is more expensive than the competitors? Maybe, but maybe not. If you're a high quality brand wanting to project a high quality image, then it's really not that big a deal. Okay, so this is the basic price premium formula, comparing your price to a benchmark price. But what the benchmark price is can be lots of things. This was a very basic example where we're using the competitor's price as the benchmark, but it could be other things as well. And we're going to go through a couple of those. So you see here the second formula, weighted average price premium. Weighted average price paid. Okay, so basically what we're going to do is instead of comparing ourselves to one competitor, we're going to compare ourselves to a select group of competitors. Maybe it's all competitors, just depending on the information you have available. And so one kind of piece of logic is to weight the average price, okay? And you do it to reflect market share. So if 50% of the market buys brand B and 30% buys brand C, then the average price in the marketplace is going to be different than just the basic average of those two. So we can weight the prices in the marketplace. Okay, so Acme sells bricks for $2. We also know from research we have a 40% market share. Our three closest competitors are Beta. We've already talked about them, $1.84. Their market share is 20%. Gamma, their bricks are even cheaper, $1.76. Their market share is 30%. And then finally, Row is the most expensive competitor, $2.15. That reflects 10% market share. Okay, so the question is, what is the price premium based on this weighted average price paid? Okay, so again, we weight it to reflect, the percentage volume in the marketplace. You could just do a basic average of the three, and then just do it that way and make that the bench price. But it's more accurate, more valid, I should say, to go ahead and do the weighting. So the weighted average price premium is just a sum of all the prices times all the market shares. So $2 times 0.4, 184 times 0.2, 176 times 0.3, and 215 times 0.1. Add those all up, you get a weighted average price paid of 191. Use that as your benchmark. You end up with a price premium of 4.7%. So you're more expensive than the average, but not by a lot. Okay, hopefully that makes sense. If you don't know market shares, you can do what I've mentioned before. Just take the average price. So you could take the average of 184, 176, and 215. Whatever that average is, then becomes your benchmark. Plug that into the formula and get that. But if you can get market share numbers, it can be a little bit more valid. Okay. Know that you can also weight prices based on numeric distribution, ACV, PCV, concepts we've certainly already talked about. So let's kind of look at that. So works a little bit like the weighted average price paid, but there is an extra step, and that's the division. So you're going to sum up the price times numeric distribution for all the brands, and then you're going to divide it by the sum of all the numeric distributions. Okay, so it looks like this. Average price displayed is basically each price times each numeric distribution. Okay, and you're going to divide that by the sum of all the numeric distributions, which is going to be those four numbers only. That gives you 1.96 as your average price displayed. So this just reflects the relative availability of each brand's products compared to the others. So your price premium then becomes 2.04%. So it's a little bit even smaller. So if you get into a situation where you're doing some pricing analysis and your boss comes to you and says, hey, I think our prices are too high, what do you think? And you can tell that they've done a price premium calculation only using one competitor or the average price in the marketplace. If you have this information, you can do some more calculations to give them some more detailed information. Maybe the answer is yes, maybe the answer is no. Okay. All right, now let's talk about reservation prices and good value. So basically, a reservation price is the highest price a consumer will pay for a product. Okay, so if you know what the consumer's highest price paid is, you can use that information to help determine, prices. The price you could charge. Okay, and so based on that, you can figure out what percentage of the marketplace is willing to pay at the price that you charge. So here's an example here. So in this particular example, at $20, 100% of the marketplace says it's good value. At $30, 100% of the marketplace says that's a good value. At $40, some drop off. Now you're at 91%. At $50, another drops off. You're now at 82%. At $60, another one drops off. Now you're down to 73%, and so on and so on. So basically, at $20, 11 out of 11 consumers say it's a good value and thus are willing to pay that price. At $30, it's also 11 out of 11. At $40, it's 10 out of 11. At $50, it's 9 out of 11. And on and on and on and on you go down. Okay. If you know the variable cost per unit, and hopefully you will, this can help you determine just basically what your total contribution will be at different pricing levels. So at $20, everyone says it's a good value, they would buy it, but you're losing $40 each unit if you're charging $20. So your total contribution is going to be negative 40 times 11, or negative 440. At $30, you're losing $30 a unit. 11 are willing to buy it. Now you're losing $330, and it just kind of goes on and on and on. So you can see that the price point here that maximizes your total contribution is $100. That will give you a demand of 4 based on good value of 36%. So 100 times 60 is $40 contribution per unit. 40 times 4 is 160. Okay. So based on pricing analysis, this is the price you should charge, $100. Okay. So are you cutting out some of the market? Yeah, sure. You could sell more units if you could make more profit per unit if you sold it at, I'm sorry, you could sell more units if you charge 90 bucks or 80 bucks or 70 bucks, but at the end of the day, your contribution or your profit per unit is going, total profit across all units sold is going to go down. So this is your ideal price to maximize contribution. Okay. Let's talk a little bit about economics here. So microeconomics, kind of search your memory banks for whenever you took that course, and remember you probably drew lots of graphs that included price and quantity demanded. We can use that knowledge to determine price and quantity, at different price to determine quantity demanded and vice versa. So two concepts important to know in this regard is maximum reservation price. Again, reservation price is the price that the highest price that someone is willing to pay. Okay, at $5, no one is willing to pay that price. At $4, 2 are willing to pay that price. At $3, 4 are willing to pay that price, and on and on and on and on. Maximum willing to buy is the number of people, the maximum number willing to pay a particular price. And more specifically, we're talking about when the price is zero. What is the maximum you could sell at $0? That becomes your maximum willing to buy. And it's a weird concept to wrap your head around, this whole idea of selling products for $0. But it's just part of the economic formula that we need to calculate a number of things. So if we know that our maximum reservation price is $5, our maximum willing to buy is $10, we can determine a lot of things. Okay, so here's a formula here for determining quantity demanded. Okay, so we have our maximum willingness to buy, we have our maximum reservation price, and we have our price point. Okay, so we can plug in information to come up with the quantity demanded. So I will give you maximum willing to buy, I will give you maximum reservation price, and may give you a list of price points, and you'll need to do a couple calculations to determine where is the maximum quantity demanded and possibly where is the maximum total contribution reside. Okay, so let's give an example. Company Pioneer Bicycles, they sell bicycles, not super high-end bicycles, but still okay bicycles. We know that the maximum reservation price is $300 for a bicycle. If you're a cyclist, you'll know that's crazy. That's a super low price for a bike, but this is just for illustrative purposes. Okay, at $0, the maximum willing to buy is 5,000 units. Okay, so we can plug both of those numbers in, given a price, and that will determine or give us a quantity demanded. Okay, so let's say our price is $200. Okay, quantity demanded ends up being 1,667. So you want to make sure that you round this number, just round it to the nearest. So if it's 0.5 or above, go up. If it's 0.4 or below, go down. So in this particular situation, with a maximum willing to buy of 5,000 and a maximum reservation price of $300 at the price of $200, this will be your rough quantity demanded. Okay. So if we know our variable cost is $150, given the other information, we can determine what our total contribution would be at different price levels. Okay, so remember, variable cost is not reflected here. It's not labeled, but you can find it right here. $150 is our cost to produce one bicycle. Okay, so the question is, given these price points between, in $25 increments from $150 to $300, at what price point is our contribution maximized? Okay, so basically you'll take this formula and use that to calculate quantity demanded for all 7 of these price points. Okay, And then once you get that quantity demanded, you'll take that number and multiply it by the contribution per unit, which is going to be price minus variable costs. Okay, so 150, so this is going to be 150 minus 150, 175, this is going to be 175 minus 150, and so on and so on. You run all these calculations, you'll find out that even though the maximum quantity demanded is 2,500, that the maximum total contribution comes at a price that gives a quantity demanded of exactly half of that 2,500. Okay, so the maximum total contribution is going to be almost $94,000 at the price of $225. Okay. So hopefully you can see when setting prices, it's not about necessarily maximizing quantity demanded, it's about maximizing that total contribution. Okay, so that's how this works. You'll definitely have to answer some questions or fill out a table that looks like this on the homework, as well as most likely on the next exam. So make sure that you understand this. If you don't have a clear handle on what's going on, just let me know. But again, you're just using this formula right here. I'll give you the other information. Maximum quantity demanded, maximum reservation price, and then you'll just plug in the given price points here and here, and you plug in the variable cost there, and then you just kind of run through the calculations. There's not much to it. Okay, what if I give you other information and make you solve for maximum willing to buy or maximum reservation price? These are the formulas that you're looking for. Be careful in the book. For whatever reason, there's a typo. The book does not include this multiplied by Q1 for MRP. So make sure that you stick that in there. Okay, it's not clear why that happened. If it's just a typo or an oversight, it's a pretty major one. Okay. So another example using these formulas. Jenny sells Christmas trees. Okay, she knows at 50 bucks she can sell 75 trees. She knows at 60 bucks she can sell 55 trees. Assuming linear demand, and that's what we're doing here. Okay, if we go back here, the line is perfectly straight, so we're assuming linear demand here. Assuming linear demand, what is the maximum willing to buy? And what's the maximum reservation price? Okay, so for maximum willingness to buy, we just use this formula right here. This is P1, this is Q1, this is P2, and this is Q2. You just plug everything in. You end up with maximum willing to buy at $0 of 175 trees. Okay, and then for maximum reservation price, again, plug the numbers in, and you will end up with $87.50. That's the maximum reservation price for a Christmas tree. As an aside, once you're out working and you start a family and you start buying Christmas trees, unfortunately, you could end up with trees that cost a lot more than $87.50. But for purposes of this example, that's the number. It's pretty high, but again, the price that companies can get for Christmas trees nowadays is pretty crazy. Okay, so we've been talking about linear demand. Okay, so we're assuming linear demand. There's also what we call constant elasticity. So elasticity is this whole idea that change in price will impact change in quantity to some degree or at some level, and just know that the change in quantity varies per change in price for different industries, for different consumers, all kinds of things. If a price change significantly changes quantity demanded, that's going to be an elastic price. If change in price doesn't change quantity demanded that much, then you have an inelastic price or an inelastic good. Okay. Good examples of inelastic goods would be energy. So gasoline, natural gas, stuff for fuel for heating your home in the wintertime. those are basically necessities. And so, even if the price goes way up, you're still gonna uh, need to purchase it, okay? Whereas things like, if movie tickets went from $10 to $20, it would greatly, harm demand much more than if the price of gas doubled, okay? So elasticity, we can use this formula to calculate linear demand. If we have information related to both two different prices and two different quantities, we can calculate the elasticity, assuming demand is linear. If demand is not linear, if it's got a curve to it, then there's another formula that you have to use. So just know that is involves, it could be, you could use this formula, but it's not going to give a totally accurate picture because there is that curve in the chart. Okay, so not going to make you calculate elasticity at all. But wanted to let you know kind of what we're talking about. So implication is if you're in an industry where products are significantly elastic, you got to be more careful about price changes than if you are in an industry where they aren't necessarily so elastic. So that's it. If you have any questions, don't hesitate to let me know. Thanks.